So to start off Unit 2, we've got a few things we're going to go over here today. First thing I want to cover is this. If I have a fraction, 3/4, we know that that means we have 3 of something. And the thing that we have is those fourths. But what if it is negative 3/4? Well, if we had negative 3 inches, which I know is kind of silly, but that means we're 3 inches short of having how much we need. The negative, of course, there pretty obviously goes with the 3, doesn't it? So technically when we have negative 3/4, since the 4 is a name and not really a number, the negative should go with the 3. This is a negative 3 of those fourths. We're missing 3 of those fourths. But in practice, I can have that negative 3 out front like this, and I can either put it with the 3 or with the 4, because here, of course, that's telling me that it's 3/4 and the whole thing's negative. But here, if I put the negative with the 3, with the numerator, what's a negative divided by a positive? A negative. Or here, if I put the negative with the denominator, what's a positive divided by a negative? A negative. So when I have a signed fraction, a negative fraction like that, I can either put the negative with the numerator, the denominator, or leave it out front. It does not matter. Sometimes it's easier when I'm multiplying by certain things. Let's say I have, I'll write that so it's negative 3/4 times 12. Well, when I go to multiply that out, I'm going to make that negative 3/4 times 12 over 1, and there I did it again. I keep wanting to slide the negative up there. When I look at this, in order to work with that negative, it would be easier if I put the negative with the 3, like this. The reason it would be easier is because that 4 is going to cross cancel out. 4 and 12 both divide by 4 to give me 1 and 3. So now I have negative 3 times 3 is negative 9. So negative 9 over 1, or just negative 9, is my answer. There may be times where it's easier to put the negative with the denominator. Now, for our purposes here, all the applications I can think of are stuff that are beyond this course. Like if you're looking at ratios, like a slope ratio where you go rise over run. If it's a negative 3/4, the negative means you go down 3 and over 4. But if you wrote it as 3 over negative 4, that would mean you go up 3 and back 4. Well, the resulting slope is still the same. But again, that's something that we're not going to learn in this course. Not to jump from one topic to another, but the big topic for today deals with our powers. 10 to the third power like that means what? How would we calculate that? 10 times 10 times 10. And I know we've seen powers before, but we're going to take kind of a focused look at them today. 10 times 10 times 10, of course, is 1,000. 1K. Nice. So anyway, 10 to the 5th power then is going to be what? Got 5 tens multiplied out, which comes out to be 100,000. Do you guys remember the shortcut when you have powers of 10? Yeah, the power tells you how many zeros there are going to be. So the 5th power means there's 5 zeros on the end of it. Perfect. Let's see how well you remember your powers. 10 to the power of 0 is? 0. I figured most people would say 0. What's it going to be? Anybody remember? There you go, 1. The pattern looks like this. 10 to the third is 1,000. What's 10 to the second? 10 squared. 100. 10 to the first is just 10. Each time I reduce that power by 1, what happens to this number? It's divided by 10. I reduce that by 1. This is divided by 10. So 10 to the 0, I reduce the power by 1 again. 10 divided by 10 is 1. Well, since we started on that path, let's keep going. What would 10 to the negative 1 be? Nope. Divide by 10 again. 1 divided by 10 would be 1/10. 10 to the negative 2 dividing by 10 would be 1/100th. 10 to the negative 3 is going to be 1,000th. Yep, 1/1000th. You'll see there is a correlation here. 10 to the positive 3 is 1,000. 10 to the negative 3 is 1/1000. A negative power, not just a fraction, but it is a reciprocal. So if I have 3/4 to the power of -1, what does that mean? It means I'm taking the reciprocal. That just means 4/3. The reciprocal of it. Well, technically, like here, 10 to the -1 means 1/10. Negative 3/4 to the -1 means 1/3/4. Well, what's 1 divided by 3/4? That's 1/1 times 4/3, which is 4/3. So yes, it turns out a negative power is just a reciprocal. So if I have 2/5, by the way, to a power, the power of 3, for example, what's that going to be? 2/5 times 2/5 times 2/5, right? 3 2/5 multiplied together. Well, if I look at this, when I multiply fractions, I multiply numerators, right? 2 times 2 times 2 is 2 to the 3rd, or 8. Multiply denominators. 5 times 5 times 5 is 5 to the 3rd, or 125. So when I have a fraction to a power like that, I can take the numerator to that power and the denominator to that power. So if I have 1/3 to the power of 5, I can treat that as 1 to the power of 5 over 3 to the power of 5. What's 1 to the power of 5? 1. 1 to any power. 1 times, I can multiply as many 1s together as I want to, and I'm going to end up with 1, right? 3 to the power of 5 is 5 3's multiplied together is 243. So 1/3 to the power of 5 is 1/243. What is 1/3 to the power of -5? Well, you can treat the negative and the power separately. What does the negative mean? It means reciprocal. So what's the reciprocal of 1/3? 3/1. And now it's to the power of +5. So you can do the negative separate from the rest of the power. So now it's 3 to the 5th over 1 to the 5th, which is 243 over 1, or just 243. You can see that ends up being the reciprocal of what it was, 1/3 to the 5th power. So just to practice that, 2/5 to the 6th power. Of course, that'd be 2 to the 6th over 5 to the 6th. What's 2 to the 6th power? 64, right? What's 5 to the 6th power? There you go, 15,625. So now, what if I had 2/5 to the power of -6? There you go, just reciprocal. 15,625 over 64. Or it'd be 5/2 to the power of 6. Oh, the fraction's negative? Oh, good point.
Oh, my God. What is a fraction?
Without calculating this, -5 to the power of 4. Can you tell me, is that going to be positive or negative? Why is it going to be positive? Because it's an even power. Even powers are always going to be positive no matter what the number is that we start with. So if I have -7 to the power of 3, that's going to be negative because it's an odd power. odd powers on a negative number, it can be a negative result. So that's going to be negative 343. So what if I have negative 2 to the power of negative 9? Well, first of all, I can do it in either order. I can do the negative first. So this is now negative 1/2 to the power of 9, like that. So I do the negative part of the power first. Or I can do the 9 part of the power first. Negative 2 to the power of 9 is negative 512. Then I still have the negative part of that to do. So I did the reciprocal of negative 512 is a negative 1 over 512. Negative 1/2 to the power of 9, well, that's negative 1 to the power of 9 over 2 to the power of 9, which is a negative 1 over 512. Same difference. So the negative still depends on whether the negative on the number here still depends on whether the power is odd or even. The negative in the power will always be a reciprocal, no matter whether the power is odd or even. Does that make any sense? It's kind of heavy, isn't it? So 10 to the 6th power is going to be how many zeros? 6 zeros with the 1 in front of it. 10 to the negative 6th power, we said, was the reciprocal of that. Well, the decimal version of 1 millionth looks like that. There are not 6 zeros there, but there are 6 what? Decimal places. So when it's a negative power, the power is not the number of zeros, it is the number of decimal places. 10 to the negative 3 then can very quickly be calculated to be what? Don't give me the name of it, just spell it out. 0.001. 3 decimal places because it's the power of negative 3. So let's say I have 10 to the 5th divided by 10 squared. Now we can calculate this out, 10 to the 5th being 100,000, 10 squared being 100 divided out. But let's keep it as powers for now. 10 to the 5th, of course, means 5 of them multiplied out. 10 squared is 2 of them multiplied out. We remember from our reducing fractions that we can cancel out common factors in the numerator and denominator. Cancel out one 10, cancel out another 10, what's left? 3 tens, 10 to the 3rd power. If I have 10 to the 7th divided by 10 to the 5th, I've got 7 tens on top, 5 tens on bottom. I'm going to cancel out 1, 2, 3, 4, 5 of them. Somebody said it. What am I left with? 10 to the 2nd. I've got 2 tens left on top, 10 to the 2nd power. Obviously, you found the shortcut. What's the shortcut for finding this power here? Subtract. 5 minus 2 makes 3. 7 minus 5 makes 2. So, what if I had 10 to the 18th divided by 10 to the 11th? 10 to the 7th. 18 minus 11 is 7. So what if I have 10 to the 4th divided by 10 to the 9th? 10 to the negative 5th. The other way I could have looked at that, 4 tens over, I really should have picked something other than 9. I can cancel out 1, 2, 3, 4. I'm left with 1 over 10 to the 5th. which of course is the same as 10 to the negative fifth. How about this one? That's going to be 10 to the 7 minus a negative 5, isn't it? 7 minus negative 5 is 7 plus a positive 5. So you are correct. 10 to the 12th power. What's this one going to become? It'll be 10 to the negative 2 minus 8. Negative 2 minus 8 is negative 2 plus a negative 8. So negative 2 and negative 8 makes?
10.
Negative 10. So 10 to the negative 10. Good. So what's this going to become? 10 to the negative 5th divided by 10 to the negative 9th. Negative 5 minus a negative 9, which will become negative 5 plus 9, right? Plus the opposite. So negative 5, positive 9 ends up at 10 to the positive 4. So those negatives do come back to haunt us a little bit. So what about ten to the third times 10 to the fourth? Well, 10 to the third is 3 tens. 10 to the fourth is 4 tens. If I multiply those all together, how many tens do I have multiplied together right now? 7. So it's 10 to the 7th. Some of you probably already see the shortcut there. What is it? Yeah, 3 plus 4. So 10 to the 9th times 10 to the 21st is going to be 10 to the 30. 9 plus 21 is 30. So 10 to the 8th times 10 to the negative 5th is going to be what? 10 to the 3rd. 8 plus negative 5 is 3. Positive 8, negative 5 ends up at 3. 10 to the negative 7th times 10 to the 12th. So we've got negative 7, positive 12. It is 10 to the 5th. 10 to the negative 3rd times 10 to the negative 11th. 10 to the negative 14. You got it. Negative 3 plus negative 11 is going to be negative 14. So when we're multiplying, since we're adding the powers, it's a little bit simpler. What's that mean? Well, it means we're going to have 4 10 to the thirds multiplied together, right? If I wrote these all out, I got 10 to the 3rd there, I got one there, and one here. If I'm multiplying those all together, I have how many total 10s multiplied together? 12. 10 to the 12th. And you said it, the shortcut is if I have a power raised to another power, I can just multiply those. 3 times 4 makes 12. So if I have 10 to the 7th to the power of 11, I'm going to get 10 to the 77th. Good. 10 to the 9th to the power of negative 3, I'm going to get 10 to the negative 27. Good. Of course. 10 to the negative 5 to the power of 6. 10 to the negative 30. Negative 5 times negative times a positive is a negative. How about 10 to the negative 8 to the power of negative 5? 10 to the positive 40. How about this? Okay. Well, I can do this in a couple of different ways. I can do the power first, or I can do the division first. Now, order of operations says technically I should do the parentheses first. Since I can combine the 10 to the third and the 10 to the eighth, I should do that. 10 to the third divided by 10 to the eighth is going to be 10 to the... What do I do with these powers? The 3 and the 8, I'm going to subtract. So 3 minus 8 is a negative 5. And then to the power of 5 is 10 to the negative 25. Negative 5 times 5 is negative 25. So how about this one? 10 to the negative 4th divided by 10 to the 8th is going to be what? Negative 4 minus 8 is going to be negative 12. Negative 4 minus 8 becomes negative 4 plus a negative 8, which is a negative 12. But I still have the power of negative 3 out there. So yes, negative 12 times negative 3 is a positive 36. How about this one? 10 to the 4th divided by 10 to the negative 9th to the power of 7. 10 to the 4th divided by 10 to the negative 9th is 10 to the 13th. 4 minus a negative 9 becomes 4 plus 9, so 13th. So now I do have to do the 13 times 7, which is 91. 10 to the 91st. How about this one? What do I have to do first here? Well, I should do the top first, right? 5, 10 to the 5th times 10 to the negative 8th would be 10 to the... I'm going to add powers because I'm multiplying. 5 plus negative 8 is a negative 3. Next, I should do the division here. 10 to the negative 3 divided by 10 to the negative 9th is going to be what? Negative 3 minus, because I'm dividing, a negative 9, is negative 3 plus 9, or 6. So 10 to the 6th. And I still got a negative 3 out there. 10 to the negative 18. Lovely, huh? Sure. I'm going to have you guys try one in your notes. So 10 to the 7th times 10 to the negative 3rd over 10 to the negative 9th times 10 to the 5th, and then all to the power of negative 5. Give that one a shot. Where do we start on this one? I'll do what's on top. 10 to the 7th times 10 to the negative 3rd is 10 to the 4th. We add, when we multiply, we add the power, so 7 plus negative 3 is 4. Hang in there. On the bottom, what do we get? Negative 9 plus 5 is a negative 4. So now we divide. 10 to the 4th divided by 10 to the negative 4th. 10 to the positive 8. 4 minus a negative 4 becomes 10 plus 4, or 8. To the power of 5. 10 to the negative 40th. Good. Why are we so worried about these powers of 10? Well, if you got into algebra, by the way, you could put x in there where 10 is, and you do the exact same calculation. Combine the powers the same way. We're not going to get into that in this class, just so you know. But if you ever went on to something else, you'd see that. For our purposes, however, let's look back at our place values again. we know that this is the ones place, tens, hundreds, thousands, 10,000s, and so on. 100,000s. This is the 1/10th place. This is the 100th place. This is the thousandths place, and 10,000ths, and so on. If we look at those are just our powers of 10. This is 10 to the 0, 10 to the 1, 10 squared, 10 to the 3rd, 10 to the 4th, 10 to the 5th, 10 to the 6th, 7th, and so on. This is 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4. Well, we are used to abbreviating numbers. For example, I might have 8,200,000. If I were abbreviating that, I would probably call that what? 8.2 million. Right? Sound familiar? Rather than writing out the word million, however, I could just look up here and see, hey, that is the 10 to the 6th place. So instead of writing 8.2 million, I could write 8.2 times 10 to the 6th. And some of you might recognize that as our scientific notation. All scientific notation is looking at the first digit of the number, naming its place value, and then putting the decimal point after that first digit. So if I have 0.0019, now I'm looking at the first non-zero digit. I should be specific. The first non-zero digit here is the 1. What place value is that in? The 10 to the it's the thousandths, or the 10 to the negative 3. So I put the decimal point after that digit. So it's 1.9, and then that's saying that that digit that's in front of the decimal point is in the 10 to the negative 3rd spot. That's what scientific notation is. Or I might have 750,000. So I'm going to put it as 7.5. So I have one digit in front of the decimal point. What place value is that 7 in? 10 to the 5th. So times 10 to the 5th. That's all scientific notation is. It's naming the place value of that first digit. So that digit that's in front of the decimal point, the power of 10 is naming its place value. Now, rather than writing out these place values every time to convert a number to scientific notation, which I certainly don't want to have to do that, there's a shortcut. And it's probably the way most of you have been taught to do scientific notation. If you want to take 47 million and put it in scientific notation, of course, we're going to make it 4.7 because only one digit, one non-zero digit in front of the decimal point. And then instead of looking at the chart and finding the place value of the 4, how are you taught to define the power of 10? How many places you have to move the decimal point. Decimal point, if it's not written, is always at the end of the number. And it has to move 1, 2, 3, 4, 5, 6, 7 spots. 10 to the 7th. Now, if we were to look up here, that 10 million spot is the 10 to the 7th spot. But that's the shortcut. You're just looking at moving the decimal point. So if we had 0.00091, I'm going to make that 9.1 times 10 to the, how many spots do I have to move my decimal point? I'm going to move it to here, so 1, 2, 3, 4. It's not going to be 4, though. It's going to be negative 4. And we know that because this is on the side of the decimal point that has the negative place values. Now, you were probably taught some rules. You move the decimal point left, it's a positive power. Move the decimal point right, it's a negative power. All you really need to know is the big place values are positive place values, and the little place values are negative place values. If you know that, you don't have to worry about what direction you're going. So, if I have 0.0000083 and convert those in your notes quick to scientific notation for me. What power of 10 is going to go here? -6. It's in the negative side. The decimal point had to go 1, 2, 3, 4, 5, 6. What power of 10 is going to go here? 8. This is definitely the positive side. We had to go 1, 2, 3, 4, 5, 6, 7, 8. So if I give you scientific notation, 3.8 times 10 to the -4th. To convert that back into standard notation, of course, the 4 is telling me I have to move the decimal point 4 spots. The negative is telling me that this is a small number. It's a decimal number. So I know that I have to move the decimal point to the left to make this smaller. How many places? 4. So I can go 1 spot, then I got to fill in zeros. 2, 3, 4. There's my decimal point. So this is 0.00038. Or I could have 7.2 times 10 to the 5th. The 5 is telling me my decimal point has to move 5 spots. It's positive, so that means this is a big number. So I have to move the decimal point which direction? To the right, 5 spots. So 1, we've got to fill in zeros again. 2, 3, 4, 5. So that's 720,000. So in your notes, (5.4) times 10 to the 8th and 3.6 times 10 to the -7th. Convert those back into standard notation, or standard or decimal notation is what it would be called. So what's the 5.4 times 10 to the 8th going to become?
540 million.
Perfect. We have to move the decimal 8 places. It's a positive, so it's a large number. So 1, 2, 3, 4, 5, 6, 7, 8. So 540 million. Oops. Hopefully put the last 2 zeros on there. 3.6 times 10 to the -7 becomes... Okay, I will just do it out. So we start out with 3.6. And -7, of course, means it's going to be a small number, a decimal number. So we got to move 7 spots to the left. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 3, 6. So that's actually 3,600 millionths. In your book, on page 121, exercise 2.4, 1 through 45, the odds. On page 125, exercise 2.5, 1 through 29, the odds. And on page 130, exercise 2.6, 1 through 57, the odds. Goes over the powers of tens, combining the powers of tens, and then moving the decimal point for the scientific notation. On Thursday, we'll go over operations with numbers in scientific notation. So we'll see why we did all this stuff with powers of 10 today.